is Begoña Espiña. I'm Galician. I studied marine biology in the University of Santiago de Compostela, and I did my PhD research based on the study of biotoxins, their toxicity, and new methods for developing their detection and quantification. I finished this PhD studies in 2009. Afterwards, during 2 years, I was working mainly in the technical management of 2 Interreg European projects. And these projects were devoted to the development of new detection methods for biotoxins, as well as studying their possible therapeutical uses. After that, in 2011, I joined INN as a research fellow in order to develop nanotechnology-based detection methods for biotoxins. After 2 years, I became a staff researcher here. I was heavily involved in the setup of the laboratories, and after getting some grants and external funding, we were able to fund our research group that is water quality. Our group activities are very much aligned with the European Green Deal, particularly to get the zero pollution goal, as well as the United Nations goal number 6, that is related with the sustainable water management and attaining water sanitation for all. This year's World Environment Day is devoted to ecosystems restoration. River, lakes, oceans and coast restoration highly depend on the better sustainable management of the waters, as well as avoiding its contamination and better control of the management of those resources. Very much in line with this, our research group develops mainly 3 research lines. The first one is devoted to water treatment. And for this line, we design, fabricate and test new nanomaterials and nano or microstructure surfaces to avoid to decontaminate water, to avoid pathogens immobilization in the surfaces, and to restore water purity. One example is, for instance, our design and tailoring of porous materials such as this one, that is covalent organic framework, that we develop in collaboration with Nanochemistry Group here at INN, and that we can use it's a novel material and we can use to very efficiently absorb contaminants such as pesticides, pharmaceuticals, biotoxins, and this will help us to purify the water. One particularity of this material is that it is magnetic, so as you can see, we can remove directly from the water, or here as dispersed. And this allows us to remove the material itself from the water. But it is very important for us to take into account which could be the impact of the nanomaterials when we use them in the environment. And that's why we are developing a second research line that is devoted to eco-nanosafety. We develop and carry out methods for evaluating nanomaterials fate, bioaccumulation and ecotoxicity following the OECD guidelines or establishing new methods adapted to the reality of nanomaterials. Currently, we participate in several European projects which main aim is to evaluate and mitigate the risk of nanoparticles and nanoplastics in the environment and for human health. 3 of them are coordinated by Spanish institutions. And we coordinate another one, the Interreg Atlantic Area Project Nanoculture. Finally, our third research line is devoted to water monitoring, which pursues the development of new portable or unassisted sensing systems for biological and chemical contaminants in water, with a special emphasis on persistent organic contaminants, such as some pesticides, pharmaceuticals, or perfluoroalkyl substances, biotoxins, and pathogens. Our main aim is to be able to produce devices, modular or integrated, that can be used on the spot and with minimal or inexistent operator participation, avoiding the big delays in obtaining results that in many cases prevents an efficient management of risk and helping to obtain an early warning system. We develop prototypes based on electrochemical signals and in Raman spectroscopy, such as the ones that my colleague Laura Rodriguez-Lorenzo will explain next.
I'm Rodriguez-Lorenzo. I studied chemistry and I did my PhD in nanotechnology in the University of Vigo, Galicia, Spain. After that, I moved to Switzerland to work for 5 years in the Adolf Merkel Institute, and after that I applied to INL with a Marie Curie Caffan Fellowship, and I granted. And after that, recently I received the FCT Scientific Employment Grant. We have 3 lines, research line, and the third research line is the water monitoring. And in the past years is the line that I work in more. Mainly in my case, I work in the development of surface, engagement, Raman scattering sensors for the detection of very different contaminants in water, from nanoparticles until biotoxins. Why we wanted to develop sensors with this technique is because SIRS, that we shorted now, has very high sensitivity and selectivity due to the NISA spectroscopy technique. This means that you can imagine that the molecules, when interact with the light, start to vibrate. And these vibrations are related to the structure of how the molecules are in the environment, let's say. And with this one, you recall a spectra that contain many peaks that have a specific pattern for this specific molecule. And with this one, you can detect several molecules or several contaminants at the same time, and also a very low concentration. And it's for that we can do it in a small sensors, let's say. Then we integrate the search substrate that normally you need to use metal nanostructures, than mainly gold, because are very stable, and with this one you can have no problem with the stability in the environment. That is one of the problems with this type of sensors. And with these ones you can immobilize to create a different type of chambers to detect inflow in the water, and then you can monitor it inside. And it's for that we are now developing different type of prototypes based on these techniques.